Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides additional practice in using permutations and combinations to calculate probabilities. Let's get started. Okay, here we've got another example where we're looking at the number of ways we can arrange the letters in the word. And the word for today is hippopotamus. You know, I love this picture of the hippos because, when I see that, I think about that game I used to play as a kid called Hungry Hungry Hippo. Have you ever played that game? If you haven't played that game, okay, for a little kid, it's actually a pretty fun game because you just go at it trying to gobble up all these little marbles. And, I remember having fun with that game. I remember breaking that game more than once, actually, because you get a little too rough with the lever there. But, yeah, lots of good times there, good memories. Hungry Hungry Hippo. So if you've never played it, check it out, look into it. You might have yourself a good time. Anyway, back to the problem here. How many ways can the letters in hippopotamus be arranged? Okay, we know how to work this problem. First, we're going to count the number of letters in the word. So how many letters do we have in the word hippopotamus? Go ahead and count. Okay, I hope you counted 12 letters because that's what we got. 12 letters. Now the next thing we're going to do is, I hope you just said that we're going to look for how many letters are repeated. So how many letters do we have repeated here? Go ahead and count those out. Okay, you should see that we've got 3 of the letter P and 2 of the letter O. So now we know this information. Now we're ready to set up our factorial fraction. Okay, so here we set it up, 12 factorial over 3 factorial times 2 factorial. Remember, the 12 comes from the fact that we've got 12 letters total. The 3 comes from the P being repeated 3 times, and the 2 comes from the O being repeated 2 times. So now we've got our factorial fraction. We just punch that out on our calculator, and we get this amazing number, 39,916,800. This is the total number of times, total number of ways that the letters in hippopotamus can be arranged. Let's look at another example where we're asked to find how many ways can you make change for a quarter. Okay, we're not counting different arrangements of the coin separately, so the order doesn't matter here. So, gee, how many different ways can we actually calculate for the quarter? Well, we're making change for a quarter. We're going to be using pennies, nickels, and dimes. How many different arrangements can we expect to have? Well, there's no magic formula here, so the only way to create our sample space is to just consider each possible outcome individually and then count them up. So to start out with, let's just say we've got 2 dimes and a nickel. And then we're going to replace that nickel with 5 pennies. So now we've got a second outcome. And then let's say we're going to replace that second dime with 10 pennies. So now we've got a third outcome. And then we'll go back to that first outcome, the 2 dimes and the nickel. Let's replace one of those dimes with 2 nickels. So now we've got a dime and 3 nickels. And we can replace one of those nickels again with 5 pennies, another nickel with 5 pennies. If we take that last nickel here and replace it with 5 pennies, we'll have 1 dime and 15 pennies, which is this outcome we've already considered right there. So now let's go back to outcome number 4 and replace that 1 dime we have left with 2 nickels. So now we've got 5 nickels. And then we can replace each of those nickels in turn with 5 pennies. And so eventually we find that we get 25 pennies. And so these are all the possible combinations, possible outcomes. And so we count them up. There's 12 of them altogether. So that's how many different ways we can make change for a quarter. Again, there's no magic formula here. Sometimes you just have to create the sample space and then count how many items you have in the sample space. Doesn't happen very often, but once in a while, that's what you got to do. Let's look at one more example involving computer programming. So a common rule amongst people that write code is that the names of variables must be between 1 and 8 characters long. The first character can be any of the 26 letters of the English alphabet. But then, successive characters can be any of the 26 letters of the alphabet or any of 10 digits. So, for example, you could have a variable name. Here's some examples: A, B, B, M3477K. So how many different variable names are possible? We're ignoring the difference between uppercase and lowercase letters. So we're considering uppercase and lowercase letters to be the same. So how many different variable names are possible? Well, okay, so how many different spaces do we have available for us in our variable name? Let's consider a variable name that has 8 characters. So we've got 8 spaces that we've got to occupy with a character. Okay? In the first space, there's 26 possibilities for the first space, because that first space has to be a letter from the alphabet. So there's 26 possibilities for that space. But for each of the succeeding spaces, spaces 2 through 8, for each of those spaces we have 36 possibilities, because each of those spaces can be occupied by either a letter or a number. So there's 10 different digits to find the number, 26 letters in the alphabet, 10 and 26 make 36. So now we've got each of the different possibilities for each of those spaces. We're going to use our fundamental counting rule to multiply each of those together. So we've got the 26 times the 36 multiplied 7 times. We multiply that big behemoth calculation out. We're going to get 26 times 36 to the 7th power, because there's 7 36s. And that gives us this whopping total of, what is that, 2,037,468,266,496. Now, if you're like me, when I first worked this problem, you'd be tempted to say, there's your answer. But we've only considered the variable names that have 8 characters. What about the variable names that have less than 8 characters? So now what we have to do is repeat this calculation for 7 characters, 6 characters, 5 characters, so on and so forth. And when we do that, we can put our calculations into a table like this to get the number of possibilities for each of the possible number of variables. Then we add all this stuff up in the end to get the grand total at the end. And that gives us, a little bit more than what we had before, but still it's a huge, huge number, okay? So this is the answer that we're looking for. That's a whole lot of possibility. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.